Hello student, welcome to today's session. So today we will be doing session number 4 of the organic series, which we have started few days back. In the first session we talked about historical background of organic chemistry. In the session 2, chemical bonding, especially the covalent bonding required for the organic compounds. In the last session I talked about the catenation and bond line representation. If you could recall, this particular discussion we did last time, that all the corners are carbon atoms and whatever hydrogens are required to complete the tetravalency of carbon are there in this particular representation. Now today what we are going to start is with a topic which is a very important one, and after this particular topic I do say with lot of conviction that whosoever is having little less interest in organic, start loving organic chemistry, because it is very interesting. And this particular topic is being taught in a conventional style after IUPAC naming, then thereafter your general organic chemistry. In somewhere in the start or the last of the general organic chemistry this is being taught, but I am teaching you very upfront, because by knowing the concept of this particular discussion, you feel your hands start working, that if I would give you some organic formula, you are able to design different structures without knowing the aspect of functional group and what are the technical names of that compounds. That is the upcoming, and that would be done in the upcoming sessions. So the topic name is, for the today session number 4 we are into. I'm always excited while discussing this particular topic, because very interesting topic it is, the topic of degree of unsaturation. Now let us go into this particular discussion. What do we mean by degree of unsaturation? Now, as a matter of fact, if you are being given some molecular formula, just like if I would give you these molecular formulas, we are able to understand in the last class that the number of covalent, because the organic entities would have the covalent bondings, double bond, single covalent bond, double covalent bond, or triple covalent bond. This we have done in the last session, that this particular discussion we already had in the topic of chemical bonding in the session 2 or 3, that how many we can identify the number of covalent bonds in these formulas by using this in this molecular formula, how many number of covalent bonds are there. And covalent bonds are further of two types. I already have talked about single covalent bond, double and triple. And in the single, whosoever is making a single bond is having sigma, double is having 1 sigma 1 pi, and triple is having 1 sigma and 2 pi. This although we haven't yet done the technical aspect in the terms of what exactly is sigma and pi bonding, that we will be doing once we complete the IUPAC naming and homologous series. Then we will be doing the advanced level of chemical bonding. Here you just have to rely on the fact that wherever you would find double or triple bond, these would have some pi bonds, and these are also called as multiple bonding. Now the point here is that now in today's session we are able to dig deep into the topic, that those covalent bonds which we have found by this formula, what type of covalent bonds are there, can be possible in these molecular formulas. So for that we are taking up this particular discussion. So this topic, as a matter of fact, this topic of degree of unsaturation, this term in itself is having a lot of synonyms used in different demographical areas. Degree of unsaturation, many books write it as unsaturation index, double bond equivalent, DBE. Index of hydrogen deficiency is also very popular in unsaturation number, but I just always use this more often, degree of unsaturation, as DU. It just clicked me more. So what basically, let me directly write the molecular the formula for identifying the degree of unsaturation without knowing the fact what exactly does it mean, which we are going to do it in a while. So if a molecular formula is given, or molecular formula is in front of you, you just should always develop this habit of identifying the degree of unsaturation, whether you are in class 10th, 11th or 12th, or you have cleared the 12th class. Even then, if you are a dropper student, then also it would click. And I have seen with my experience that people have done entire of organic chemistry and they are not aware of the fact that what exactly do we mean by degree of unsaturation. So when they come to know about this term, then they feel little, demotivated, that we did so many things in the organic, but we did not have that idea of degree of unsaturation. What basically is degree of unsaturation? Mathematically, it is Here, this C I am defining it as number of carbon atoms, N is the number of nitrogen atoms, H is the hydrogen atoms, and X we are defining for the halogens, fluorine, chlorine, bromine, iodine. And if in a case oxygen and sulfur are there in the molecular formula and that are not to be counted whenever any formula is being given to you which is containing, just like if I would say C3H6O. So while evaluating degree of unsaturation for this formula, you have not to count about the oxygen. You have to just place carbon and hydrogen. Now let me do it for you for some molecules. Just like if I would write C3H6. Now all of these hydrocarbons, these 4 compounds which I have just selected here, since they don't be having any nitrogen and halogen, we can simply write degree of unsaturation as to be 2C plus 2 minus H upon 2. So if I would write it for degree of unsaturation for this molecular formula, du would then be written as 2 into 3 plus 2 minus 6. Am I right or not? So here we will be saying this 3 is the number of carbon atoms and this 6 is the number of hydrogen atoms divided by 2. So 3 to the 6 plus 2, 8 minus 6 upon 2. So this is 2 by 2, that is 1. So degree of unsaturation for this formula is 1. Now what exactly does it mean? We will be answering it in a while. So C4H10 if I have to write for, and for this if you have to find the degree of unsaturation, it would be 2 into 4. 4 is the number of carbon atoms. Plus 2 is to be added from the formula point of view. Minus 10 upon 2. So this becomes 0. So the degree of unsaturation for this compound is 0. Going forward like this, if I would write C5H8, so degree of unsaturation can be written as 2 into carbon atoms, that is 5 plus 2 minus 8 upon 2. So 10, this is 4 by 2. So the degree of unsaturation is 2. So this way you can find out the degree of unsaturation without knowing the fact that what exactly does it mean. But anyhow, you can do it like this. Let me do for, some compounds which would be containing nitrogen and oxygen. So here we have to use this formula du is equal to 2C plus 2 plus N minus H minus X upon 2. So if I just would go for this formula, so the degree of unsaturation here would be 2 into 5 plus 2, nitrogen atoms are 1, hydrogen atoms are 5. So this happens to become 10, 12, 13, 13 minus 5 is 8 by 2. So the degree of unsaturation is here is 4. And similarly, if I would go for this formula for this entity, so we would be writing degree of unsaturation 2 into 3 plus 2. Now how many oxygen atoms are there? That are not to be counted. Only you have to place the hydrogen atoms. So how many hydrogen atoms it has? 6 upon 2. So this again would become equal to 1. So degree of unsaturation comes out to be 1. For this again, if you would do, the degree of unsaturation would come out as to be 4. Let me take one more example, C2H4Cl2. If say for example, this is the formula given to you. So degree of unsaturation is 2C plus 2 plus N minus H minus X upon 2. So here you would find that nitrogen is not there. Nitrogen is not there. You are having with you halogen. So what I do here is 2 into 2 carbon atoms plus 2. How many hydrogen atoms I have? 4. And halogen atoms, chlorine or fluorine or halogens are 2 in number, divided by 2. So 2 to the 4, 4, 5, 6, 6 minus 6, this is 0. So degree of unsaturation in this particular compound comes out to be 0. Now you would be having a sort of, a strong curiosity. What exactly do we mean by this degree of unsaturation? So degree of unsaturation simply would mean, in one way I can say it like this: it is the sum of pi bonds and rings in a given organic compound. Now what does it mean? That I just have spoken it in a very simple word, that it is the sum of pi bonds or rings given in an organic compound. Here also I am not defining what exactly do we mean. Just if I would write it like this, this is some compound, so it is having one ring, isn't it? You could see there is 3 carbon atoms joined in a cyclic ring. So I shall be saying the degree of unsaturation for this is 1. Now what does it mean? I am going to explain it in a while. Similarly, if I just would show you that this is some compound where you have this as a double bond. So how many pi bonds are there in this compound? You are seeing there is one pi bond. There is one pi bond. One pi bond. So I shall be saying this is having degree of unsaturation equal to 1. Now I am going to define it. What exactly do I mean by degree of unsaturation? So if I have to go deep into this discussion, first I have to tell you what do I mean by saturated, because unsaturation word is coming. Degree of unsaturation, saturated and unsaturated. What does it mean? We have to understand these two terms first. That what do we mean by saturated and unsaturated? Saturated hydrocarbon or a saturated compound is the one in which you would find only single covalent bonds in a carbon chain. If you are having some carbon chain which is containing only single covalent bonds, we will be saying that as to be a saturated hydrocarbon. Saturated hydrocarbon. As a matter of fact, if you would find in a carbon chain there is some double bond or triple bond available, double bond or triple bond available, or in other words, if the compound is containing some pi bonds, we will be saying it as a unsaturated hydrocarbon. So this first difference you should know, that if in the carbon chain you are having only a single bonds available, single covalent bonds, we will be saying it as saturated. But if you are getting some double or triple bond in the compound, just like if I would show that this is some compound, here you find some double or triple bonds. So some pi bonds are there, we will be saying it is a unsaturated hydrocarbon. Now the point here is, when you talk about saturated hydrocarbon, this can be further of two types. Just see here. A saturated hydrocarbon can be open chain, which we say it as acyclic hydrocarbon, or a closed or a cyclic one. Just like the open chain hydrocarbon, saturated hydrocarbon is referred to as alkane. Now this is the first time I am introducing something technical into the discussion. Alkane. So alkane, let me first break up this. What does it mean? Alk means the number of carbon atoms. Wherever in the organic chemistry you would find this term alk, that alk means the number of carbon atoms in the carbon chain or in that particular organic compound. And wherever you would find a term written as ane, ane means single covalent bond, single covalent bond between carbon-carbon atom, carbon-carbon atoms. So this is also very important to tell you, that when I am saying something written somewhere as ane, that means that particular carbon chain is having a single bonds. And as a matter of fact, when you find anything written as alkane, this would endorse this formula CnH2n plus 2, where this n is the number, any number 1, 2, 3, 4, something like that. So if n is 1, we will say it as meth. This you have already done in 8th, 9th or 10th class. When a carbon chain is having 1 carbon meth, 2 carbon eth, 3 carbon prop, this we are going to discuss in very detail in the upcoming homologous series as well. So pent, hex, hept and so on. So this is what you always have to remember. What I am trying to say here is that when you talk of a saturated hydrocarbon, just like if I would show you like this, that I have with me this 3 carbons joined to each other with a single bonds. Now these 3 carbon atoms can also join to each other by single bonds like this also. Wow, this is interesting. You can join it like this, you can join it like this, and still it is single covalent bonds. And now you could see that how many hydrogen do it have. This is having 3, just to keep its tetravalency intact, because you have to create 4 bonds around the carbon, and that too with the single bonds. So this is what you call it as 3 carbons said as prop. And all this prop is having all that carbon, 3 carbon is containing single bonds. We will be referring to it as ane. So we can say it as propane. Am I right or not? Yes, it is perfectly right. So it can be said as propane. Okay. Now what we are doing here is, here if you could see that same hydrogens, if I would do it like this, H, now you would find that while going from this side to this side, from this side to this side, the number of hydrogen atoms got decreased. Am I right? Just like, let me do it like this also. With some superpower energy, I just have snatched out these 2 hydrogens out, such that this bond can be generated here. A bond can be generated here. That is what I did it like this. If I do so, what I am able to get here is, this again is a saturated one because there is no double or triple bond here. But the point here is, although it is saturated, but it is devoid of two hydrogen atoms to be alkane. If I just do the reverse way, what I'm trying to say here is, if I just would go the reverse way, what the reverse way is, that if I have with me this compound with me, which we call it as cyclo because it is cyclic. What is alk? 3 carbons are there, prop. So beautiful, I have showing you. And this is cyclo. And this cyclo is containing only carbon-carbon single bond. So it is cyclopropane. So now if I do the reverse way, if I would show you the reverse way, that would address the thing better. That with some superpower energy, I just have broken this bond. And while I just have broke this bond, I just have to attach two hydrogen atoms so that the covalency remain completed. So we will be saying that saturated hydrocarbon could be of two types, alkane and cycloalkane. And alkane can be also be said as acyclic saturated hydrocarbon. Acyclic saturated hydrocarbon. So what do we mean by degree of unsaturation? Degree of unsaturation simply would mean number of pair of hydrogen atoms, or number of molecules of hydrogen a given molecule lack to be alkane. What I'm saying is, just we have defined few minutes back that the degree of unsaturation for this can be said as 1 because it is having one ring. Now what does it mean? Degree of unsaturation 1 means that this particular compound, which is C3H6, could become alkane if you add one pair of hydrogen into it or one molecule of hydrogen into it. So the number of molecules or number of pair of hydrogen atoms you have just entered into any hydrocarbon to make it a saturated acyclic compound, that is what you call it as alkane, then we will be saying it as to be the degree of unsaturation as 1. So the number of pairs you have added. Now let me define it. What I am trying to say here is, in one words, we have already spoken about this, that degree of unsaturation is the sum of pi bonds and rings present in a molecule. Just like here, you can take one example. C3H6, we wrote it few minutes back. So you can write it in form of cyclic ring, or you can write it like a open chain. So both of these forms are available. So if you go to a market to buy this C3H6, the shopkeeper would say you would want cyclopropane or cyclopropene, you would want cyclopropane or propene. Now I would be saying that if I just would add hydrogen into it or hydrogen into it, this will also become propane, this also will become propane, C3H8, for which the degree of unsaturation is 0. So the number of pair of hydrogen atoms or number of molecules of hydrogen you added to a hydrocarbon so that it could become alkane or saturated acyclic saturated compound, that is what you call it as degree of unsaturation. So here we will be saying degree of unsaturation is 1, degree of unsaturation is 1. One way is because it is having one ring, or one way is it is having one pi bond. To remove this pi bond, you have to add two hydrogen atoms into it. So the pair of hydrogen atom you added is referring to that particular number of degree of unsaturation. Is it okay? So I think I made my point clear that what do I mean by degree of unsaturation is the number of, let me define it here once more for you. Degree of unsaturation is the number of pair of hydrogen atoms, because one pair contains two hydrogen atom, or number of molecules of hydrogen a given compound lack to be alkane or saturated acyclic or open chain compound. Why I am writing this as open chain this term why I am using here, saturated acyclic open chain compound, because if I have with me, say for example, if I write C3H6O, this is some compound C3H6O, for which we already have find it with the formula that the degree of unsaturation for this is 1. So that means if I just would add one pair of hydrogen atom into it, it would become C3H8O. Now this has degree of unsaturation 0 and this would have degree of unsaturation 1. So any hydrocarbon which has the tendency to take one more pair of hydrogen atom, or the tendency of taking one or more pair of hydrogen atom, the number of pair of hydrogen atoms they are taking up, that is what you call it as the degree of unsaturation of that particular compound. Now if in case I just would write degree of unsaturation is 0, that means this particular compound would not be having no pi bonds, it would not have any pi bonds, no rings, it would not have any no rings. Similarly, if I would say degree of unsaturation is 1, that means it would either have one pi bond or one ring. Now similarly, if I go for degree of unsaturation 2, so in this either of any of these cases can be there. Either I would say it is having 2 pi bonds, or it would have 1 pi bond plus 1 ring. Now this is very interesting, and or it would have 2 rings. Now as a matter of fact, 2 pi bonds can be possible. 2 pi bonds could be possible. Either it would have two C double bond C bonds or one C triple bond C, isn't it? When you have one triple bond, it is having 2 pi bonds, or there are 2 times 2 double bonds are coming. And here 1 pi bond, 1 ring means there is 1 double bond and 1 ring is there, or 2 rings. So this way we have to now explore it, because the video may go in length, but it is very interesting to explain the things. Now we start with this. So degree of unsaturation here is, so 2C plus 2 plus N minus H minus X upon 2. This is the general formula. So here we don't be having nitrogen or X. So simply I would write 2 into 4 plus 2 minus 10, because hydrogens are 10 divided by 2. So it comes out to be 0. So what does it mean? Now the things would become very interesting. That this C4H10 is not having any double bond, or so it is no pi bond. So we got a clarity, very clear clarity. No pi bond. It would have no ring. So now my hand would work fast to make the compound. So now we got this understanding that the 4 carbon atoms would be joined to each other by single bonds, because the degree of unsaturation came out to be 0. So since the degree of unsaturation came out to be 0, so this C4H10 must be having no pi bonds and no rings. So it must be having single bonds. Now someone else out of you can draw the single bonds like this also. Fair enough, nothing wrong in it. But yes, if I would draw it like this, at times people do it like this. So I will say these 3 are same. This one, all of these 3 are same. So, but this is distinct, because now if I just would place the hydrogens, now this is the beautiful thing. Now, as soon as you find there are 4 carbon atoms which can be joined it like this or can be joined it like this, definitely it would come out to be 10 hydrogens into it. Just see here. So 3 would come here, 2 would come here to keep the tetravalency intact, 2 would here, 3 here. So it becomes 10. So this is already joined to 1. So how many hydrogens you still have to place? 3. It is already joined to 1, 3 here. It is already joined to 1, 3 here. And the center one, which you are able to see, already joined to 3 carbons, and here would come 1 hydrogen. So again it is 10. So I can show you this is this compound and this is this compound. So this is this and this is this. Is it okay? So C4H10 would be available in the market in 2 forms. And sooner we would be going to understand the naming of these 2 compounds. So here we are not explaining the naming. I am just making you feel that C4H10 is having, in the previous class we have found the number of covalent bonds, how many covalent bonds it can be having. Now we are understanding, if in case you don't understand the last lecture, this lecture in itself would endorse that one. That once you get to know that the degree of unsaturation is 0, so you have to make only single bonds. So this is the beauty of the thing. Now if I would go for C3H6, so C3H6, the degree of unsaturation would be 2 into 3 plus 2 minus 6 upon 2, so it come out to be 1. So this means it either would have one pi bond, and that pi bond would be available in C double bond C, or it would have one ring. Beautiful. This we have already done few minutes back. So there are 3 carbons. The 3 carbon at least would join with each other through single bonds. But since the degree of unsaturation for this is 1, that means you have to place one pi bond either in this way, or ring is already there. So if you have drawn the ring, so degree of unsaturation is 1. So now whether you show the hydrogens or not, it would come out to be 6 only. So 3 here, 3 plus 1, 4. So already you have 2 bonds here, 3. So how many hydrogens you have to place it here? 1 hydrogen and 2 hydrogen. Let me show it once again to you. So we would be making one bond is there, 3 here. So it becomes 4. 1, 2, 3, and you have to place 1 hydrogen here more. So this is hydrogen. So 1, 2 and 2 more. So it becomes C3H6. Similarly, 2 hydrogens, 2 hydrogens, 2 hydrogens. So how bond length representation would go like? For this is this, for this is this. Both of these are what? So directly, indirectly, you are understanding very heavy topic or very interesting topic of organic chemistry is isomerism. So these two are isomers. If you go to market, C3H6 would be available in any of these two forms. One is called as propene, other is called as cyclopropane. Now going forward, if I would write for C3H6, so degree of unsaturation would be 2 into 3 plus 2 minus 4 upon 2. So 6 plus 2, 8 minus 4. So it comes out to be 2. So 2 means that because there are 3 carbons into it, degree of unsaturation 2 means that it would have 2 pi bonds or 2 rings, or 1 pi bond, 1 ring, something like that. So there are 3 carbon atoms, 1, 2, 3, 3 carbon atoms, and 3 carbon atoms you can join it like this also. Is it okay? So now to keep the degree of unsaturation of 2, you can place 2 pi bonds in the form of triple bond, or somebody can also show it like this also. 1 pi bond here, 1 pi bond here. So here also the degree of unsaturation become 2 because there are 2 pi bonds. Here also it is 2. And here is the ring. So ring is constituting 1 degree of unsaturation. So you have to place one extra pi bond here also. Now that's a different story. Whether it would be stable or not, that's a different story. Theoretically, you can make it. So here you have 3 hydrogens because this is 1. And now you could see here how many bonds we already have. 1, 2, 3, 4. So the center carbon would not have any hydrogen, but yes, here 1 hydrogen would come. Here 2, here 2. And in this case, there is 2, 1, 1. I think I'm making the point clear. So if you go to market to buy this compound, so this would be available in any of these 3 forms. Now the next example which I'm going to take up is a very interesting and a heavy one. Although this video go in length, but I am going to explain it in detail. So C5H8. Now this is very interesting, where you would really start developing this skill set that how a given hydrocarbon can be drawn in different structures. Without knowing the functional group or without knowing the what is the naming of it, that we will be doing it in upcoming 1-2 lectures. So C5H8, for which the degree of unsaturation came out to be 2. What does it mean? Degree of unsaturation means 2 means that it may have 2 pi bonds, and 2 pi bonds can be form of 2 double bonds, or 1 triple bond, or 1 double bond, 1 ring, 1 double bond, 1 ring, or 2 rings. So the 2 pi bonds can be possibly in the form of this or this, or 1 pi bond can be in the form of double bond and 1 ring. Now just see here how interesting is this particular topic. So if I would show you, there are how many carbon atoms? 5 carbon atoms. I can randomly showing you 5 carbon atoms. 5 can show it like this also, or this also. Is it okay? So if I just would say that C5H8 is having degree of unsaturation 2, that means it is having 2 pi bonds. And if I am saying that 2 pi bonds is in the form of double bond, 2 double bond, So how could I show you? How could I show you? Now this is very interesting. Although I am saying it again, the video may go in length, but it is very, very interesting. Now see here, I can show it to you like this also, or just hold on. Okay, so here we are. I can show it like this. I can make a double bond here. I can make a double bond here. One way of representation is this. I can show it like this also, isn't it? I can show you like this also, isn't it? So there are two. So now if I just would place, or if I would say two are here, so now these two are same, isn't it? Both of these are same. These two would be same. 1 2 or 1 2. 1 and 2 is having double bond, so that way it is same. So this means knowingly, unknowingly, you are getting many things out of this particular discussion. So now if I have to place the hydrogens, so here two bonds are already there, two hydrogens would come. This carbon is already tetravalent because four bonds are already there in this. So here it is 1, here it is 2, this is 3. So 3 plus 2 plus 1 is 6, 7, 8. So the hydrogens are complete. Similarly, if I go for this one, H, H, H and CH3. Similarly here CH2, here is 1H, CH2 and 1H here, CH2. So you are able to understand that with this sort of designing, you are able to see that C5H8 when is containing two double bonds can be shown in any of these form. The story is still not completed. You can draw the 5 carbon atoms like this also. Nothing wrong in it. You can draw it like this also. You can draw it like this also. Nothing wrong in it. And you have to place two double bonds. And two double bonds you can place it like this also. 1, 2 and 1. This is already 4, so I can place it here. Or you can place it here also. Isn't it? So now if I would place the hydrogens, so here you have 2 hydrogens, here you have 3 hydrogens. This is already complete. 4 bonds are already there. So 1 would come here, 3 come here. 3 and 3, 6. Here would come 2. 2 and 3, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8. So 8 has completed. So here you have 2 hydrogens, here you have 3, here you have 3. So it got completed. So this means, so with the understanding of degree of unsaturation, that C5H8 having 2 carbon-carbon double bond can be shown in any of these form. This has taken a bit of more time. If I have directly gone for a bond line representation, I would have saved my time. But I just wanted to explain it in detail. So what I was saying, these are the 5 carbon atoms. I can show it like this also. I can show it like this also. This is this one. And let me show it this one. So I have to place, to keep the degree of unsaturation 2, I have to place 2 pi bonds. I can place it like this. 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 So there can be some other forms also. Some other isomers also. I think I have completed with the. Now you have again 2 pi bonds. Now these 2 pi bonds can be in the form of triple bond also. If you have a triple bond, same formula C5H8, still the isomers are not complete. So 5 carbon atoms, you can draw the 5 carbon atoms like this. Now I would do it in a little speed. You can draw it like this also. So I am randomly making all these carbon-carbon atoms with the single bond. Now to keep the degree of unsaturation of 2, you can place the pi bonds, triple bond you have to place. So triple bond, if I will place it here, now you do at your place that count the carbon, count the number of hydrogen atoms. It would come out to be 8 only. And similarly, if I just would make it like this or just would make it like this. Now these two are same. Now this is a common sense that if I just would move from 1 to 2, so 2 position is carrying a triple bond, or from this side also the 2 position is carrying the triple bond. So these are same. And for this, if I just would make a triple bond here I cannot make. So this is a wrong representation because here the carbon's tetravalency got disobeyed. Around the carbon, this particular carbon, there are 5 bonds, which is not possible. So as a triple bond, if you go to market to buy C5H8, then the examiner is going to ask, the shopkeeper is going to ask you that would you want this one or this one or this one? Still the story is not complete. C5H8, now you can make it in a form of one ring plus one double bond. That also would make degree of unsaturation 2. So simplest of all ring, smallest of ring is the triangle, 3 carbon atoms. I'm just making it randomly. 3 carbon atoms can be shown it like this. Now you have to place, so this in a way, if I just would mark it like this, what I have drawn, C3, 3 carbon atoms, 3 carbon atoms and hydrogens are 6. So the degree of unsaturation is 1. So in this, the degree of unsaturation has came out to be 1. But we have to go for the 2 degree of unsaturation with 2 more carbon atoms because it is C5. So 2 more carbon atoms, I can join it like this. Wow, this is interesting. I can join it like this. Now to keep one double bond extra, you can make a double bond like this. Now this is C5H8. Wow. You can make it like this also. 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 But these two are same. These two are same. Now you have to apply your common sense why I'm saying it's same. Now with the triangle, it is almost complete. So that means, or no, still we can make it in a different way also. So still you have 2 carbon atoms to attach to it. So 2 carbon atoms, you can join it like this also. 2 carbon atoms, you can join it like this also. You can join it like this also. You can join it like this also. Why I'm showing it like this? Now still, if I just would make a double bond here, it is C5H8. Do it at your place because there are 5 carbon atoms. 1, 2, 3, 4, 5. In degree of unsaturation is 2. 1 from the ring, 1 from the pi bond. And here also there are 5 carbon atoms and you have to still bring in one double bond. So one double bond, you can bring it here. You can bring it here. You can bring it here. So are you able to see that C5H8 can be available in any of these forms? So interesting is this. Now if I have missed something, you can draw it patiently at your place. And similarly, if I would go for the 4 one, if you have a cyclic ring of 4 and still you have to place 1 carbon atom more. 1 carbon atom more. So how many double bonds you still have to place? 1 double bond you can place it here to make the degree of unsaturation 2. 1 from the ring, 1 from the double bond. Here also. Here also. So this way you can go this way also. And still we are left with the one more, that is the one with the ring of 5. If you have a ring of 5, ring of 5 can be shown it like this also. It is having degree of unsaturation 1. At present, it is having degree of unsaturation as 1. But if I just would make one double bond here, so the degree of unsaturation would become 2. So this in a way shows that C5H8 can be in this form, can be in this form, can be in this form, and so on. And all of these would have different IUPAC naming. So that is why I always not teach IUPAC naming directly, because first you should know how beautiful is the organic chemistry. From a given molecular formula, you can draw so many things. And story still is not complete. C5H8, and now you have 2 rings. 2 rings. Now how could you show 2 rings? One ring is this and another ring is this, isn't it? Or one ring is this, another ring is this. So this later on we will be doing. These are called as bicyclo compounds. This is called as pyro compounds. Now let me show you because you will feel more enthralled with. Carbon is the center one, and these two are the one which are joined here, and these two are the one which are joined here. And you have to place the required number of hydrogens. 2 would come here, 2 would come here, 2 would come here, 2 would come here. So it is C5H8. So as a matter of fact, if I would say that if somebody would ask you that you are being given C5H8, if you are being given by C5H8 and you are supposed to react with something, till the time you don't know the reagent which you have added for the reaction to the C5H8, till the time you don't know which C5H8 it is. Now here the C5H8 is of the type of diene. There are 2 double bonds, diene. All of these are classified under the category of diene. And if I would proceed further, these are the category of alk There is a carbon chain which is containing ine, triple bond. So is it alkyne or is it cycloalkene? These are cyclo, and along with there is a double bond also, cycloalkene, and these are the two rings, bicyclo or spiro, something like that. So this is so important and so interesting. Moving forward, let me take few more examples, although video may go in length. C3H6O. For this, you have to find the degree of unsaturation. So 3 into 2 plus 2 minus 6. Oxygen is not to be taken care of. So the degree of unsaturation came out to be 1. So if degree of unsaturation came out to be 1, now you should know that in the compound you have oxygen, and oxygen can join with somebody either through single bonds, two single bonds, or one double bond. This always you have to remember with, that it can join with somebody with two single bonds, because oxygen is having 6 valence electron. 6 valence electron can be shown it like this. So to make its octet complete, it can take one from here, or two from the double bond. So now we are finding it out that degree of unsaturation came out to be 1. That means there must be one double bond, and that double bond can be in the form of carbon-carbon double bond, or carbon-oxygen double bond, or in the form of some ring also. It can be in the ring form also. So important and so interesting has become the topic. Now I have to make all the permutation combinations which I can think of without considering the fact what is the functional group or things like that. You have to simply make the compounds. So there are 3 carbon atoms, 3 carbon atoms, 3 carbon atoms. You can join it like this also. Somebody else can join 3 carbon atoms like this also. He placed oxygen in the center, and someone else can show it like this also. Let me use the next diagram, next page only. We are C3H6O, for which we found that the degree of unsaturation came out to be 1. Oh, sorry. Degree of unsaturation came out to be 1. So since the degree of unsaturation came out to be 1, so what possible things we can make it? One possible thing I can make it like this also is that keeping this oxygen as single bond. So if I just would make the oxygen as single bond, then what possible combinations I can get with? So one combination I can get with, I just would place hydrogen here, and now what I can do here is, because degree of unsaturation is 1, although I wrote 3 carbon, 1 oxygen, but I yet not have defined the double bond or a ring. So to make the double bond, I can make a double bond here, or can make it here, isn't it? Now if you would now count the number of hydrogens available, it would be coming out to be 6. 1 already I have attached with 3 here, 1 would come here, 3 and 4, and 1 would come here. Similarly 2 would come here, 1 would come here, and 2 would come here. So 5 and 1, 6. This is one way of doing it. Someone else can join oxygen here also, isn't it? So now to keep the degree of unsaturation 1, you can place it here also. So now just see the number of available hydrogens I do have here. 2 here, this is already 4, 3 here, and 1 is this. So total has become 6. So are you able to understand what I'm doing here? And in the bond line representation, I can show it like this also. I would have shown it like this also. So here you get a double bond, isn't it? Here you get a double bond, here you got a double bond, here you got a double bond. Now what else you can think? What else we can make out of this? Sorry, what else still we can make out of here? Because we have used, now see, now if I would have used the oxygen in the form of double bond, so there are 3 carbon atoms, and you are supposed to place one double bond. So you can make one double bond like this also, or this also. And if I would join it here, 1 and 3rd would become the same one. So other possibilities are not there. So now to make the complete the tetravalency, here I will place 3, here 1, here 1. Here I would place 3, here I would place 3. So this later on we will be saying it as aldehyde. This has to be said as to be a ketonic functional group, which I am not going to speak at this point of time. And still you can think of a ring also. Now in terms of the ring, if I would show you, I can show it like this: oxygen, this, and still I have one carbon left with. So this is one carbon, CH3. So there are how many carbon atoms I have with me? 1, 2, and this is the third one, and which is having 3 hydrogens. And one hydrogen is here, one hydrogen is here. 2 hydrogens is here. So it becomes C3H6O. Let me show it once more for you. The cyclic form. The cyclic form, I just can show it like this: C3H6O. So this is oxygen. This is the one representation I can join with. Another one is this one. This I can also show you. So this is, later on we will be speaking this as to be cyclic ether. But so are you able to understand it, that I have shown you this one also, I have shown you this one also, I have shown you this one also. Still we can do some more also which I may have missed. I have shown you this one also, I have shown you this one also, isn't it? So these are the forms which we have shown, and still I am thinking that I can place few more into it. Now as soon as I do so, now just you can show it like this also: 3 carbons, 1 oxygen, and you have to bring one double bond into the system, which can be placed it like this. So this can be shown it like this also. It is again a cyclic ether. It is an open chain ether. So the point here is that if you go to market to buy this compound, this would be available in any of these forms. Now which form they are asking and which form the reaction has to happen. So that is why this particular topic is very, very important. And there is no formula, which generally people ask me, is there any formula that how many structures we can get with? That formula is not there. You have to actually do it. And this, in a way, if you keep making it like this, you would feel so enthralled with the topic that it becomes so interesting. Similarly, if I would go for C3H6O, so the degree of unsaturation came out to be 1. Just do it with the formula. Degree of unsaturation come out to be 1. So 3 carbons you have to place. 3 carbons you can place it like this, this. And now the interesting part is you are having 2 oxygen atoms, and oxygen can join with this one as well as with this one. But if you have used this one, then the degree of unsaturation came out to be 1, because there is 1 pi bond. But if you are thinking of using this, the 2 oxygen should join with single bonds, then you have to bring in double bond in a carbon-carbon chain. Just like, let me show it to you. So if I have used 1 oxygen here, 1 oxygen here, say for example, now to complete the covalent, to bring in that, because you have used it with the single bond, so you have to place 1 hydrogen here, 1 hydrogen here, so that oxygen's octet got completed, and you have to bring in degree of unsaturation 1. So 1 can be placed it like this. You can bring it double bond here, or you can place it like this also. So that's a different story whether these compounds would be existing or not, but all these permutation combinations would be possible. And this is H, and here you have 3. So 3, 3, 4, 5, 6. So the hydrogens are complete. So 2, 3, 4, and 5, 6. So hydrogens are complete. And another one, if you are using this double bond as one of the thing, you can use it like this, and you can make it like this. This particular entity you might have seen many times in your organic books said as to be carboxylic acid. So here you have 3, 2. But if you have used here something like this, this can also be possible. So what I'm trying to explain it to you is that you can develop, this is the way you need to first begin with. If you would find any formula, just like this formula is being given to you, just your hand should start making the structures. Once you start making the structures, this would open up your mind towards the organic chemistry. This is what we are going to learn for. All of these compounds, their naming, how they can be prepared in the lab, what are the chemical ways of making these compounds, and once they got made, how they are going to react further. So that is what that is the very endeavor of this organic syllabi of +1 +2. So coming back to this degree of unsaturation, so 2C plus 2 plus N minus H minus X upon 2. So here degree of unsaturation come out to be 2 into 3 plus 2. Nitrogen are 1, hydrogens are 9, divided by 2. So 3 to the 6, 7, 8, nitrogen is to be added. 8 and 9, so this comes out to be 0. So degree of unsaturation came out to be 0. So this means you have 3 carbon atoms, and degree of unsaturation 0 means, now this is very, very interesting. Let me explain it in a little more depth. We would be upcoming session, I will keep it as for the practice only. So it was C3H9N. So we find that degree of unsaturation came out to be 0. So now I know for sure that nitrogen can combine with somebody either by single bond, or one double bond, one single, or one triple bond. So since I found that degree of unsaturation came out to be 0, so this means this nitrogen must be in this form, in 3 single covalent bonds. These are not possible. That is the beauty of this discussion, that once you get the formula and once you get to know from the previous lecture how many covalent bonds are there, now what type of covalent bonds are there in this particular compound, either would they be single bonds or double bond or a triple bond, that is very interesting. Now here I can make it like this, 3 carbons, or let me do it this way. So let me show it in the reverse way. So nitrogen must be joining with single bonds. Nitrogen must be joining with the single bonds. This is interesting. So this is the way you have to do it. Just randomly make these and then start making start attaching the carbon atoms. So I can attach 3 carbon atoms like this. I can attach 3 carbon atoms like this. I can attach 3 carbon atoms like this also. I can attach 3 carbon atoms like this also. Now just complete the hydrogens. So hydrogens, if I would place, so here I would get 2 hydrogens, here I would get 2, 2 and 3. So are you able to see? It becomes 9, 3, C3H9. Now similarly, if I would proceed further, here is 1, here is 3, here is 3 and 2. It again becomes 9. And here also 3, 3, 1 and 2. Here 3, 3, 3. So very soon we would be using this as like this one. So in the bond line representation, if I would show 3 carbon atoms joined with NH2. Here also 3 carbon atoms joined with NH2. Are you able to feel it? This structure, are you able to get it? This particular one, how I have shown. So 3, so this is NH2, but there is 1 carbon here. So the carbon, carbon, carbon joined with NH2. Similarly, carbon, carbon, carbon joined with NH2. When something is directly joined with NH2, that is called as primary amine. This is not the right time to explain this. Okay, let me leave it because it would create a stress. So similarly, if I would show this one, I can show it like this, NH. So this is the NH, to which on one side there are 2 carbon atoms. On one side there are 2 carbon atoms, on the other side there is 1 carbon atom, and this simply would be shown it like this, NCH3 CH3. So as a matter of fact, if you just would want to recall it, this, when nitrogen is attached to 3 carbon atoms or 3 carbon chains, then this is called as tertiary amine, for which we will be doing the homologous series in the next sessions. And when nitrogen is attached to 2 carbon atoms, it is called as secondary amine. And if nitrogen atom is attached to 3 carbon atoms, if nitrogen atom is attached to 1 carbon atom and 2 hydrogen atoms, then it is generally said as primary amine. So this we will be discussing in the homologous series as well. So I am leaving you with some homework. So you can try this as homework. Just make the structures, keep this as homework, take this as homework. Okay, let me do this one because halogen example I haven't done. So what is the degree of unsaturation I can get with? 2C, 2C plus 2 plus N minus H minus X upon 2. So nitrogen is not there, halogen is there. So the degree of unsaturation which I am able to see is 2 into 3 plus 2 minus 6 minus 2 upon 2. So it come out to be 0. So that means it is here the halogen is attached to the carbon chain only through the single bond. So there are three carbon atoms. There is no ring, no pi bond. There are 3 carbon atoms. Now you have to simply place the halogens. How many halogens you have to place? 2 chlorine can come here. 2 chlorine can come here. 1 chlorine can come here, another one here, or 2 chlorines are onto the adjacent one, or 1 chlorine here, 1 here. These are identical. third and fourth structure are identical. You can draw it here. So now if you would place the hydrogen atoms, it would come out to be 6. 3, 4, 5 and 1 is 6. 3 here, 3 here. Here also, if you would see what shall then I be getting here in this case. 3 here, 1 here, 2 here, 2 here, 1 here, 2 here. Sorry, I just have wrote it right. Yes, 2, 2 and 2. Yes, 2, 2, 2, 6. It would come and 2Cl. So degree of unsaturation is 0. I think I made my point. And when, just for your knowledge base, when a given compound is attached to two halogens, a given carbon atom is attached with two halogens, we will say it as geminal dihalide. Just keep this into your knowledge bank. And when two halogen atoms are onto the adjacent carbon atoms, then we call it as vicinal dihalide. This is the common name we generally refer to. When a given carbon is attached to, when a given carbon is having two halogen atoms attached to it, then we will say it as gem dihalides or geminal dihalides. And when two halogens are onto the adjacent carbon, we call it as vicinal dihalides or vis dihalides. This is out of the way. Now, if I just would ask what is the degree of unsaturation of this compound, we will be saying degree of unsaturation is 1 because there is one ring. Degree of unsaturation in this is it would be 2 because there are two rings. And if I would go for this C6H6, are you recalling? In the first lecture, I said you that C6, if somebody would ask you what is C6H6, knowingly, unknowingly, everyone speak that it is benzene. No, C6H6 would have degree of unsaturation 4, and from this particular 4 degree of unsaturation, you can generate almost more than 217 structural isomers, the way we have drawn for the other compounds in today's lecture. So there are, if you could recall or just would see those who are new, in the session 1 I have shown you that C6H6 can be represented in theoretically in more than 200 forms. So that is so beautiful, and out of that 200 forms, this particular part, this particular design is called as benzene, for which the degree of unsaturation is 4. Why is it 4? Because there is one ring and 3 pi bonds. 3 pi bonds. So that makes the degree of unsaturation as 4. So I am leaving you with one important question which I am going to discuss in the next class. So this is, you have to tell me the degree of unsaturation for this compound which we call it as cubane. If I start discussing this, this would again take another 10 minutes. So in the upcoming session I am going to discuss, and this particular compound is called as cubane. You have to find the degree of unsaturation for this, and you also have to tell me that when cubane is hydrogenated, that particular compound that we refer to as cubane, that this particular compound which is C8H8 is being hydrogenated to make a saturated alkane. If you are wanting to make it a saturated alkane, which of the following is formed in out of all of these, which would be formed if you would hydrogenate it? So this particular discussion I will do it next time. So hope you have enjoyed today's session. It was little more, content based and important one and interesting one. So degree of unsaturation simply would mean the number of pi bonds or rings in a compound, or a compound, the number of hydrogen atoms or pair of hydrogen atoms a given species lack to be a saturated acyclic hydrocarbon or alkane. Thanks a lot. Hope you have enjoyed today's session. Hope to meet you once again in the next session, where we will be doing more problem solving based on the degree of unsaturation. Thanks a lot, and thereafter we will start with the IUPAC naming. Bye bye, take care, have a nice day.